In this video, I'll teach you about 5 probability distributions in one go. Using concepts and techniques, I'm going to show you how to identify all 5 probability distributions. So here we have all the 5 distributions: binomial distribution, negative binomial distribution, hypergeometric distribution, Poisson distribution, and last but not least, normal distribution. So how to identify all these distributions? So first you have to analyze the situation what is given in your problem. So first I will talk about the difference between binomial and hypergeometric distribution. Here in binomial distribution, we have the problem of width replacement, or here the repetition is allowed. It means the probability of success is constant throughout the trials. Width replacement means the object we select can repeat. So whenever we have the problem of width replacement or the probability is constant throughout the trials, then we use binomial distribution. Now in hypergeometric distribution, we have the problems of without replacement or repetition is not allowed. Now what does it mean by without replacement? So in without replacement, the object we select cannot be selected again. So here the repetition is not allowed. So the probability of success vary from trial to trial. So whenever we have the case of without replacement, we use hypergeometric distribution. So the basic difference between binomial and hypergeometric distribution is the probability is constant throughout the trials in binomial distribution, that it is the case of with replacement, and in hypergeometric distribution we have the problem of without replacement, that the probability vary from trial to trial. So in the problems of binomial distribution, we are given with the probability of success because it is constant throughout the trial, but in hypergeometric distribution, probability is not mentioned. We will talk about it in detail in the next slides. Let's move towards the next distribution, that is Poisson distribution. So in Poisson distribution, we discuss rare events. So what does it mean by rare events? That the probability of occurrence of the event is very, very small, that we have a large number of trials, but the probability of occurrence of that particular event is very, very smaller. So these types of events are called rare events. So whenever we have to deal with rare events, we use Poisson distribution. Next, we have the normal distribution. So in the problems of normal distribution, the data is normally distributed. So whenever the data is normally distributed, we can deal it with normal distribution. So it's just a child play to identify that the problem is of normal distribution. So in the problems of normal distribution, it would be mentioned that the data is normally distributed. So to pick out the distribution, you must be very aware of its parameters. So now what is parameter? Parameter is a numerical values that defines a system, or it sets the conditions of its operations. So every distribution have its own parameters. So let's suppose in the problem of binomial distribution, this problem would surely contain its parameters. So if we have good knowledge of the parameters of each distribution, we can easily identify this problem is of that particular distribution. So in the binomial distribution, we have its parameters n and p. Now what is n and p? N is number of fixed trials and p is probability of success. Next, we have negative binomial distribution. So in negative binomial distribution, we have two parameters which are k and p. So k is number of successes and p is probability of success. In hypergeometric distribution, we have three parameters: capital N, small n, and k. Now, what is capital N? Capital N shows the number of units in your population, and small n is number of units in your sample space, and k is the number of successes in your population. So how can you judge the statement that whether it is the problem of binomial distribution or hypergeometric distribution? So here the main difference is in binomial distribution, you are given with the probability of success. You would be given the value of probability p because it is constant throughout the trial. So, and it is the parameter of the binomial distribution. So you can easily identify that this problem is of binomial distribution. But in the problems of hypergeometric distribution, there is nothing like probability. So in its parameters are capital N, small n, and k. So the situation would be like there is a lot of population. So from that lot, I have to pick some random sample of some objects. So these are small n, and here in this population, we have these number of successes. So whenever you have this type of situation, it is the problem of hypergeometric distribution. And in hypergeometric distribution, as we already discussed, here we have the situation of without replacement. Mostly the problems of hypergeometric distribution, it would be the problems of testing or inspection. So whenever we test different objects, we test it once. By testing it once, we can get its status that whether, let's suppose, it is damaged or non-damaged. Well, in Poisson distribution, we have one parameter. This is mu, and it is the average or arithmetic mean. I will talk about it in detail in the next slide. So moving towards the next distribution, normal distribution have two parameters, mu and sigma. Now here mu again is average or arithmetic mean, and sigma is standard deviation. Now you should be very clear about the parameters of each distribution. So in the problems of distribution, what we are interested to find is very important. So basically we are interested to find the probability of x. Now, what is x in the distributions? So in all the distributions except negative binomial, x represent the number of successes. Means in every distribution except negative binomial distribution, we are interested to find the probability of number of successes. What is the chances that we get these numbers of successes? But in negative binomial distribution, the situation is very different. Here, x is the number of trials at which success occurs. So in negative binomial distribution, we are interested to find the probability that I would get this success of this number of trials. In negative binomial distribution, I find the probability that I will get success at this number of trials. Well, now you should be very clear about what you are going to find. So in negative binomial distribution, you are basically going to find what are the chances that I'll get the success at this number of trials. And in the rest of the distributions, you are going to find that what are the chances of getting this number of successes out of all the trials. Now let's have some details on Poisson distribution. So in Poisson distribution, we have two categories. One is the direct Poisson distribution. In the direct Poisson distribution, the parameter mu is equal to lambda into t. Now what is lambda and t? Lambda is basically the average value per some quantity. This quantity could be time, distance, volume, area, it can be anything. So in the statements of Poisson distribution, it would be mentioned we get this number of successes on average per unit time or per unit area or per unit distance or anything. So and here t is the time at which we are interested to find the probability of success. In the second category, we have the simple binomial distribution, which we approximate with Poisson distribution. Now, which kind of problems are approximated by Poisson distribution? So Poisson distribution is basically for the rare events. So whenever in the binomial distributions we get the rare events, then it is more accurate to use Poisson distribution. So in the binomial distribution, we have the parameters n and p. Now here the parameter of the Poisson distribution is mu. So for the binomial distribution, mu is n multiplied by p. So in this case, the mu would be n multiplied by p because we are given with only these parameters. The simple binomial distribution problems in which n is very large value, that is number of trials is very large and the occurrence of that event is very smaller, that is the probability of success is very smaller value, then we get a rare event. So it is better to solve these type of problems with Poisson distribution. So in Poisson distribution, the statement would be like you are given with the average number of successes per unit time or unit distance, unit area, unit volume. In the second category, we would have a simple binomial distribution problem with the parameters n and p. But here n is very large number and probability of success p is very small number. So we would prefer to use Poisson distribution here. So in all this discussion, I hope now you would be very clear about all the distribution and you can easily identify which distribution should be used in which situation. So the basic key is practice. So do practice as much as you can to get perfection.